So I'm going to be going through the study guide that we went over in class today just to make sure that if you needed to hear it again or if you wanted to see how we did it in class, you have the video, you have me talking through it. I will also have the PDF of the solutions posted online. We'll start with the targets. These are the targets that we're going to be looking at on this. Read and write integers, find absolute value, compare and order integers, use the additive inverse property to make zero pairs. We're going to be adding, subtracting with integers, finding distance between two rational numbers on a number line, multiply, divide with integers, and then we're going to do some fraction and decimal work. The first problem we have says simplify. So I'm looking at this problem. I want to read this as the absolute value of negative 15 plus the absolute value of 11. Absolute value is a type of grouping that as we go through, we have to deal with the groupings first according to our order of operations or gems. So the first thing I want to do is look at this. Absolute value of negative 15. Absolute value asks me to find how far is negative 15 from 0. So this is going to be 15 plus the absolute value of 11, which is going to be 11. Now that I've got the absolute value out of the problem, I can just do what the problem asks me. 15 plus 11 is 26. The next question says replace the blank with a less than, greater than, or equal sign to make the sentence true. Again, I want to make sure that I have like numbers in this case. So I have a 5 and I have the absolute value of 3. First thing I'm going to do is just 5 remains 5. The absolute value of 3 is 3. Now I have similar numbers that I can compare. 5 is greater than 3, so that means that 5 is greater than the absolute value of 3. The next one has the absolute value of negative 17 compared to the absolute value of 16. I'm going to go through. This is going to be 17 and 16. Now that I've taken that absolute value out of it, I can compare these two numbers, and 17, or the absolute value of negative 17, is greater than the absolute value of 16. For number 3, we move into the second target, and we're going to be ordering a list of integers from least to greatest. Again, we want to focus in and make sure. Take a moment, underline that least to greatest. Identify what you're doing. I like to go through then and figure out, well, least are going to be either my lower positives or typically the negatives in this case. So I'm going to go through and I'm just going to circle all of my negative numbers. And then I'm going to go back through and underline the positives. This kind of helps me keep track of what numbers I have in the problem. So I'm going to start with the least. So I look at my 3 circled. Negative 6 is the smallest of those. Negative 4, negative 1. And now I move on to my positive numbers. So it'd go 3 and then 5. I double check. I have 1, 2, 3, 4, 5 numbers in my list. 1, 2, 3, 4, 5 numbers in the original question, so I know that I fulfilled all the pieces. The next question says, on Monday in Elmhurst it felt like negative 13 degrees Fahrenheit, and on Wednesday it felt like negative 10 degrees Fahrenheit. Which day was colder? Again, we want to notice that colder. So if I look at this, I'm dealing with negatives, so the further away from 0 the number is, the colder it's going to be. So the answer to this question is Monday. Negative 13 is going to be 3 degrees colder than the negative 10. Our next question here says graph the set of integers on a number line. Be sure to have proper scale. This proper scale is talking about the distance between these tick marks, these little lines that go into the number line. We want to make sure that between each of those you have the exact same value. My suggestion here is to focus on the number line first. I'm going to look and see. Negative 5 is my smallest number, 2 is the greatest number. I don't need to put the 0 in the center and go from there. I want to go through and just make sure I have what I need. So I like to number every other, and I like to number by evens. So I'm going to start with negative 6 on my far side. That ensures that I get my negative 5 in, and then I'm just going to go through negative 4, negative 2, 0, 2, 4. I could keep going. I don't have to because I know 2 was that largest number, and that's where I need to stop. So now I'm just going to go through my list. I have 2. So to graph 2, I'm going to put this is the graphing aspect of having my dot on that intersection of the tick mark and the number line. Next number is 1. So I'm going to find 1. I'm going to graph that. -5. I'm going to come graph -5, -2. And the last one is -4. And again, focus on that number line, get that organized. That way the graphing aspect of it is much easier and allows you to be more efficient with your process. The next 2, these are ones that are typically a little bit difficult to take the idea out of the problem. Right here, determine the following situations are examples of 0 pairs. We want to be able to look at the integers that are being represented. So if I look at this first one, I see up 7. Well, that's going to be a positive 7. And then I keep reading, I see, oh, here's the next number, down 7. Well, down 7 is going to be -7. Because I know that 7 plus -7 equals 0, these are opposite numbers, the same distance from 0 in opposite directions. One's positive, one's negative, that this is a 0 pair. The next problem, we gave out 20 tests, so that's a positive 20 and graded 20, which is another positive 20. And on this one, 20 plus 20 is going to be 40, so this is not a 0 pair. They're the same distance from 0, but they go in the same direction. So that eliminates that idea of opposites. The next problem we have, the next 4 problems are dealing with addition. First thing I want to look at is, am I adding 2 numbers with the same sign or with different signs? In number 8, these 2 numbers have different signs. So I ask myself, which one is more? Which one do I have more of? In this case, I have more positives. Because I have more positives, I know my answer is positive, and I can subtract the other value. 15 minus 4 is 11. Number 9, -23 plus -14, they're the same sign. So I start with a negative value and I add more negatives to it. So I just get a greater negative number. So -37. When I have more than 2 terms, I want to take the time and really look. I can only add, subtract, multiply, divide 2 things at one time. So I want to go through and I want to start my problem. I box what I'm going to be solving, and then I just bring this +4 down because I'm going to do that next. So I look, I have a positive and a negative. I have more positives. 13 minus 5 is 8, and 8 plus 4 is 12. So I end up with an answer of positive 12. Whenever I have a problem where there's a variable and I need to substitute, that's the first step that I want to do. So I'm going to substitute in, instead of 17 plus k, I'm going to write 17 plus -22. Now I have my problem, and now I can look at it and say, well, I have more negatives, so I know my answer is negative. 22 minus 17 is going to be 5, so I have an answer of -5. The next section we have is the subtraction. We talked about using the additive inverse here. If students are at the point where they are able to not use that, that is great. That is where our ultimate goal, but the additive inverse is an example, and I'll show that on one of these. The one thing I highly suggest, though, that we still remember is that when I see I'm subtracting a negative number, that we change this to adding. So instead of subtracting a negative, that's the equivalent to adding that value. -4 plus 13, I have more positives. So my answer is going to be positive 9 after I do the math there. If I use the additive inverse on a problem like this, I have -6. Instead of subtracting, I'm going to add, and I do the opposite of what I have. So that's positive 2, so now I have -2. I'm adding the same sign, so I keep the sign and add the numbers. Now we could also think about that as, if I have -6 and I'm going left, I'm taking 2 more away, I end up at -8. On this one, 18 minus 25, again, I see I'm subtracting more than I had, so that's going to be negative, and then 18 minus 25 is going to be the negative 7. On the third one, just like before, I'm going to go through and I'm going to box out what I want to solve first, bring the rest of it down. Negative 11 minus 6 is going to be negative 17. I'm subtracting a negative, so that was the same as taking my negative 17 plus 9. Now I look, I have more negatives, so my answer is negative. 17 minus 9 is 8. And the last problem I have on this page, negative 17 minus, I'm going to substitute my value for b, which is negative 4. Again, I see this subtracting a negative, so negative 17 plus 4. I have more negatives, so my answer is negative 17 minus 4 is going to be 13. The directions for number 17 say write an expression that represents the distance between P and R. Well, when I look at this, I see the number line, I see P and R, I want to realize where I am. So P is at negative 1. I know that's one spot left of 0. And I could double check. That's 1, 2. And that does make sense that 3 would be next. So I have the two values. I want to write the expression that represents the distance. So all I'm looking at here is to show the absolute value of their difference. So negative 1 minus 2. I have my expression. This is what I could use to figure out the distance. Or I could write this as 2 minus negative 1 as well. Either of those two things would get me to the correct answer. Again, I take the 2 points that I have. I'm going to find the absolute value of their difference. So subtract them and find the absolute value of this amount. On January 18th, the temperature was negative 7 degrees Fahrenheit. On January 23rd, the temperature was 28 degrees Fahrenheit. Find the change in temperature. So I'm looking for what's that distance between these two values. So I start absolute value of negative 7 minus 28. Close my absolute value, and I'm looking at what I have. Negative 7 minus 28 is negative 35. The absolute value of negative 35 is 35. So the change in the temperature was 35. In this case, we could explain that a little bit more by saying it was 35 degrees. On 19 through 24, we're dealing with multiplication and division. On multiplication or division, if I have the same sign, it's going to equal a positive number. If I have different signs, it's going to equal a negative number. Now again, this is when I'm applying it to two numbers. I multiply two things at a time, divide two things at a time. So we have to keep that in mind as we go through. I have same sign, so I know my answer is positive. 18 divided by 3 is 6. Different signs, I know my answer is negative. 6 times 13, well 6 times 10 is 60. 6 times 3 is 18. 60 and 18 is 78, so negative 78. Negative times a negative is a positive. 15 times 5 is going to be 75. The last one, I have grouping. The fraction bar is a form of grouping, so I need to solve everything above and below that division bar. 22 minus 8 is going to be positive 14. 16 plus negative 9 is going to be positive 7. And then 14 divided by 7, again, they're both positive, so I get an answer of 2. I have a variable, it tells me what it is, so my first step is to substitute. This is negative 14k. A number next to a variable tells me to multiply, so when I go to substitute in, I want to put the number within parentheses. And I end up negative 14 times positive 9 is negative 126. And the last problem we have here, z equals negative 132. Find z divided by negative 11. So negative 132 divided by negative 11. Negative divided by negative is a positive. I know 11 squared is 121, and I need one more set or group of 11. So my answer is 12. The next two problems. Leroy bought a shirt for $15 and spent $8 on a tie. Write and evaluate an expression to represent the situation. After you evaluate the expression, explain what the value represents in context. So I'm going to look. If I spend $15 for a shirt and then I spend another $8, this means I'm combining the $15 I spent on the shirt plus the $8 I spent on the tie, which means that in all, we have this negative 23, or Leroy spent $23. And that would be explaining that value in the context. Is you're just explaining what does that mean in the situation that you were given. Kristen climbed 5 flights of stairs in 1 minute. If she continued at this rate in 12 minutes, what is her change? This is unrealistic. No one's climbing this much this quick. But it's just, again, the idea of how to set up the problem. So if 5 in 1 minute, we want to know for how many in 12 minutes. So we're going to multiply. 5 times 12 is 60. So this would be 60 flights of stairs. 60 flights of stairs in 12 minutes. On the last page, the first thing we have here is using the idea of our number chips. Write and evaluate an expression to represent the model. Well, I'm combining these two things, so that means that I'm adding, and I'm just going to look. I have 3 positive chips, and I have 4 negative chips. So if I have 3 positive and 4 negative, I mean, I could look over here. That is a 0 pair, that is a 0 pair, that is a 0 pair. And I can even look here. I have more negatives. 4 minus 3 is 1, so my answer is negative 1. For 28 and 29, we need to convert each fraction to a decimal. 2/8 is easy, even if I think about simplifying this to 1/4. 1/4 I know is decimal 25. This one does terminate. That one does terminate, so I would circle terminating. I had to apologize. This one will not continue. So if we change this to 5/6, 2 and 5/6. I don't know 5/6 off the top of my head, so what I can do is I can do a little long division. I know I'm going to have 2 point something because I had 2 holes here. Those 2 holes will stay the same. I'm going to do 5 divided by 6. 6 does not go into 5, so I add my decimal and a 0. I'm going to bring my decimal directly above it. Now I can just look at the numbers. 6 goes into 50 8 times. 6 times 8 is 48. 50 minus 48 is 2. No, I still have to go. That's not a 0. So I add a 0, bring it down. 6 goes into 20 3 times. 3 times 6 is 18. I subtract. 20 minus 18 is 2. And now I see a pattern. Every time I go from here on out, I'm going to end up with this 3 that gives me the 18. And when I subtract that from 20, I'm going to end up with the same cycle again. So once I've seen this pattern go 2 to 3 times, now I can see that my 3 is going to repeat. So I could write this as 2.83 with a repeating bar over the 3 only. That's the only number that repeats, and I'm going to put repeating down here for my circle. The last 3, going from a decimal to a fraction, all we have to do is read it properly and make sure that we set it up that way. First number after the decimal is the tenths. The second one is the hundredths. So this is 4 hundredths. Well, I know that I can divide each of these by 4, and I end up with 1/25. This is going to be 4 and 65 hundredths. Well, ends in a 5 and a 0, so I'm going to divide both of these by 5. I get 4 and 13/20. That's simplified as far as I can go. And the last one, 7/10, and that is the simplified version right there. Hope this was helpful. Please feel free to give me any feedback.